All right. So molality, sounding very much like molarity. I didn't make the names, just teach it. But it has a different formula. So molality compared to molarity, molality is a number of moles of a solute in kilograms of solvent. The other one was liters of solution. Sometimes when you just separate out the solvent, it makes it a little bit more difficult. Not really on these so much, but the ones we are doing tomorrow, it does make it a little bit more difficult. And the unit is a little m instead of a big M. So little m is equal to moles solute divided by kilograms of solvent. I don't see this concentration measured in this very often. And probably one of the reasons is when it says kilograms of solvent, usually our solvent's some kind of liquid and we're more likely to have it in a volume measurement than in a mass measurement. So that's kind of makes this a little bit difficult. Just to remind you, if I have 235 grams and I need to get that to kilograms, it's just like moving between liters and milliliters. It becomes 0.235 kilograms. Also, like I said, it's more common for your solvent to be given in a volume. So sometimes you can use density to make that conversion from volume to mass. We'll see in a minute when we do a problem. It's really easy if you have water because the water has a mass of 1 gram per 1 ml. So if I know how many grams I have, I know how many mLs. Not so with everything else. So for example, let's say that you have 100 milliliters of oil, some kind of oil, and I tell you that its density is 0.92 grams per 1 ml. And you need to get that into kilograms because that is my solvent. So you're going to get it out of volume and you need to first get it into grams. So that's what you would use your density for. So I have 100 mils and somewhere down here I want to get to kilograms. So if I use my density first, that'll take me from milliliters to grams. So I'm going to say 1 milliliter is 0.92 grams. And when you're given a density, that doesn't affect your sig figs. It's not considered a measurement at that point. And then here to get to kilograms, I could say 1,000 grams are in 1 kilogram. So if I look at my units, everything cancels except for kilograms, and that's where I wanted it to. I would just do this little math problem, and I think I get 0.92 grams. Did anybody do it? I get 0.92. Times 0.92. No, I should have put it top. Oh, no, 92 is what I should get. Yep. 0.092 grams. So you may see that on some of the problems. All right, so let's just look at a few of those. Of course, if you look at the very first one, calculate the molarity of a solution prepared by dissolving 15.4 grams of calcium hydroxide. I'll move this up a little bit. So that is KOH and enough water to make 750 grams of water. So that's 0.750 kilograms of water. That's my solvent. So we don't have moles of my solute. We have grams. So we're going to have to use a molar mass like we do very often. 15.54 grams. And I need that converted to moles. So should my number be getting larger or smaller? It should be getting smaller because I'm going to divide. So that means my molar mass, which is 56.11 grams per 1 mole, And at this point, I have 4 sig figs, so I will say 0.2770 moles. We've done that quite a bit. So now I'm ready to plug it into my formula, 0.2770 moles. We said this became 0.750 kilograms. Because I brought that 0.750 in, it goes down to 3 sig figs. So I end up with 0.369 little m molality. I still have some people like giving this answer 0.369. That is not considered using a unit with your number. So that answer will not be wrong. I did this. We did the same thing when we were doing molar mass. You've got to have your unit with your number. All right. Any questions on this one? Kind of looks a little bit familiar. All right. Let's see what we got going on in our next one. So if we look at our next one, we have our molality. So we're trying to figure out something about our solute, which is calcium chloride. It says how many grams of calcium chloride will be dissolved in water to make 350 grams of a 1.75 molal solution. So I'm gonna go ahead and change this to kilograms. So it becomes 0.35 kilograms. It only had 2 sig figs to begin with, so it can only have 2 sig figs when I do my conversion. So here I have my little m, and I have how many kilograms? 0.35 kilograms. So I need to figure out how many moles. And then once I'm in moles, I can get to grams. So we bring this up and multiply, and we would get X is equal to 0.61 moles of my calcium chloride. That's my solute. And now, because like I said, you can't really measure moles on a balance or scale, I need to change it to grams. That's more realistic. So I would have to look up the molar mass, and the molar mass of calcium chloride is 75.53 grams. So multiply across, our number should be getting bigger. 2 sig figs would be my answer. And I got 46 grams. So if I measured out 46 grams of calcium chloride and added it to 350 grams of water, which is the same thing as 350 mils, I should get a 1.75 molal solution. I don't really ever use this concentration strength. It's not very common, but we get to learn it anyway. All right, and the last one is just kind of showing you how easy if you are working with water. It says, what is the molality of a solution that has 43.7 grams of sodium phosphate dissolved in 750 mils of water? So that is my solvent, but it's in a volume unit. Luckily, the density of water is 1 gram per 1 ml. So if I have 750 mLs, that's the same thing as saying I have 750 grams, which would become 0.750 kilograms. So if it's water, you don't have to do all those things I showed you an example of. You just can make that quick comparison, that quick changeover from volume to mass. All right, and then of course we don't know how many moles, so we got to use our molar mass to get there. 0.03, and we need to get that to moles. So I'd have to do the molar mass, which is 85 grams. My number's going to get smaller because I'm dividing 0.514 moles. And now I'm ready to finish out because I have my moles. I need to divide by my kilograms, which I have over here. That will give me 0.685. All right, 0.685 little m solution. Anybody have any questions about that? Those pretty similar to what we did, kind of work we did with molarity with big M, except maybe this we didn't have to worry about. All right, the other formula we're going to look at today is called the dilution formula, and it is a very realistic formula. I do use this one, and the formula is M1V1 is equal to M2V2. So M1 is the molarity, going back to molarity, of the stock or strong solution. So it's cheaper for me to buy a small thing of something that's very strong or very concentrated and dilute it with water than to go ahead and get all these pre-made different strengths. This also takes a lot less storage room. So those very strong molarity solutions are called stock solution. You'll see that used, and it's just the strongest molarity. So V1 is the volume of the stock or the strong solution, how much you had to use of that. Excuse me. M2 is the molarity of the final solution. And the only thing that makes this formula tricky sometimes is V2, because V2 is the volume of the total final solution. So in that final solution, I'll have my volume of solvent, but I also have added to that the volume of the stock solution. So when you figure out V2, that's not just telling you how much water you need to add to your stock solution. That's telling you how much you will end up with at the end. So let's say I have a little beaker and I need 100 mils of some solution. So I need to use 10 mils of my stock solution. So I would put that in there first. That would be my real strong one. I said that I wanted to end up with 100 mils. So now that means I'm going to add 90 mils of my solvent, which will probably be water, H2O. So when I find V2, V2 includes both of those things. It includes the total at the very end. So we'll come to a problem in a minute. If it asked you how much water you needed to use, what would you have to do to get there? Yeah, you would just take your V2, right, and subtract how much you used of your V1, and that would tell you how much water. So that's really the only thing that makes sometimes this a little bit confusing. To help you out a little bit, M1 is always greater than M2. M1, your stock solution is always going to have the higher molarity. And then your volumes are opposite. V2 is always greater than V1. Because what you're trying to do is take a small amount of something very concentrated and get a large amount of something weaker, usually done for monetary reasons. All right, let's look at a couple of those before the bell rings. All right, we'll just start off at the very beginning. I'm just going to jot my formula down. B1, 2, B2. All right, how would you prepare 485 mils of a 0.39 molar solution of sodium chloride when 1 molar is all I had? So this is my stronger one. So this is my M1. This is my M2. This is my B2. And what I'm trying to find is my B1. Your volumes can be in anything as long as they're the same. So if you have one in milliliters, the other one has to be in milliliters, or the same thing with liters. So I'm gonna start filling out my formula. M1 is what I'm trying to find. No, I'm not trying to find M1. How about V1? All right, so M1 is 1 molar. V1 is what I'm trying to find. M2 is my 0.39 molar, and V2 is my 485 mLs. All right, so you're going to multiply, bring your 1 over, doesn't change it. And when you solve for that, you should get a V1 of 190 mLs. And that's just 2 sig figs because this 0.3, well, actually we had a couple of things that were just 2 sig figs. So that's my V1. If this went on to ask you how much water did you have to use as your solvent, how would you figure that out? Yeah, I would take my V2, which was my 485, and I would have taken my 485 and I would have subtracted my 190. And that difference would have told me how much water that I used. All right, let's see where we look at one more and then y'all can try the other ones at home. So next one says, if 300 mils of a 2.5 molar solution of nitric acid is added to 500 mils of water, what is the molarity of the dilute solution? So this first molarity, 2.5, is that M1 or V1? That would be M1, right? Because I'm trying to find the molarity of the dilute. So that's always going to have to be my M2. So that means this is my V1. Excuse me. I'm trying to find M2. But what is my V2? It is 500 milliliters of water plus 300. That's right, because we said that V2 is going to be the very final. So we're using 500 mils of water, but we added that to our 300 mils of stock. So your V2 is 800 mils. So once again, easy formula, just sometimes that little thing can make it a little tricky. So once I've done that, I just start plugging in. So 2.5 molar. I started with 300 mLs. I'm trying to find M2, and I said at the end I had a total of 800. Should my M2 be more or less than 2.5? Less. So that's another kind of quick check you could do to make sure you hadn't done a calculator error. So M2 I got was 0.94 molar. Y'all try these two at home, this one and this one, see if you can get them figured out. And then we were going to move on to percent concentrations, which are definitely not my favorite. So we will struggle on through it. And then probably Wednesday, we'll do some type of practice with working in pairs. And then I don't think y'all have to come here on Thursday. I think y'all leave beforehand. We're not going to do anything extra. We're going to just practice on some of the practice that we have. Oh yeah, y'all already went on. You won't even come here. It's just first and fourth. Yeah. But if you aren't going to be here on Thursday,